Hello everyone, I am Dr. RCS Chauhan, Associate Professor, ECE IET Lucknow. Today we will discuss the information theory and coding. This is subject in final year electronics and communication engineering, KEC 075. In this subject basically in 5 units information theory and coding, then information basically it is related with the digital communication. In digital communication basically the source of information basically that we will discuss in the unit first. Entropy of the source, basically that is the average information, mutual information, chain rules of entropy, and long sum inequality and its applications, data processing inequalities. And in second unit we will cover basically the source coding theorems. In that asymptotic equipartition property, basically consequences of AEP, data compression, high probability sets of typical sets of data compressions, and examples of codes. These are the Kraft inequality optimal codes. These are the source codes basically. Source of the first block, that is in the digital communication system, and bounds on the optical code lengths, Kraft inequalities, Huffman codes, bounds, Shannon, Fano, Elias coding. These we will cover in the second unit. In third unit basically the channel capacity. Here we will cover the channel coding theorems, and basically to improve the error performance of the channel, we will do some channel coding in the block of channel encoder, and here we will discuss these topics: channel capacity for various binary channels, properties of the channel capacity, channel coding theorem and channel capacity theorem. And in fourth unit we will cover basically block codes, and in fifth convolutional codes. These cover in the that is the coding theory. Basically these are the channel codes which are used to correct the errors occurred in the channel. In block codes, basically introduction, single parity check codes, Hamming codes, minimum distance of block codes, soft decision decoding, definition of linear block codes, error detection and correction, parity check matrix. And in last fifth unit we will cover the convolutional codes. Here encoding convolutional codes, generator matrix for convolutional codes, generator polynomial for convolutional codes, graphical representation of convolutional codes, Viterbi algorithm for decoding of the convolutional codes, and binary cyclic codes, BCH codes, RS codes and Gole codes, that we will cover in the unit 5th. Okay. This is all about the syllabus that we will cover in the coming lectures. Okay. Here also we can see that unit 1st, 2nd and 3rd, that covers the information theory and source coding basically, but unit 3rd, some part of 3rd, 4th and 5th will cover the channel coding, block and convolutional codes, as I have discussed in the last slides. Before to start from unit 1st, in the that is the entropy, I have to connect the syllabus of this subject with the basics of this, that is the digital communication system. Okay. How digital communication system connects with the information theory. Okay. Then we will discuss firstly in the first lecture basically basic block diagram of digital communication system. Okay. Here after that in the next lectures we will discuss about signal, message, information, and information in common sense, information and uncertainty, information in engineering sense, binary information, average information and so on. Then we will come to the unit 1st. Okay. The first topic of the unit 1st. Before that we will cover these topics which will connect this information theory and coding with the basic digital communication system. Okay. Next, the pre-syllabus, basically to connect with the syllabus, there are some topics we will discuss so that we can understand from starting. Before going in detail, we will first discuss the basic block diagram of a digital communication system. Okay. In that block diagram of a digital communication system, how it connect with the information theory and coding, we will correlate with this. See, these are blocks in basic elements of a digital communication system. First is the source, this one, then source encoder, channel encoder, digital modulation, channel, digital demodulation, channel decoder, source decoder and destination. We can group these blocks. Whatever information from the source will emit to the next block, that information will receive at this block of destination. Okay. Then we can group these blocks, source and destination. Okay. Whatever information, that may be analog or digital. Okay. Whatever information passing to the next block, that same information will be coming back from the last block, second last source decoder to the destination. Okay. Similarly, source encoder, okay, at this block, the whatever signal or information coming from the source encoded at the source encoder, in the same way it is decoded at this block of the source decoder. You can say whatever method you are using, it is a reversible method. Okay. So that whatever information you are transmitting, that received same information. Okay. It may be it can be a unique way of encoding and decoding. Okay. Then we can two blocks can grouped like this. Next block is the channel encoder and here channel decoder, while next main block channel is far away. See, when you are passing the information from source to source encoder and to these blocks, this is basically transmitter part and it is the receiver part. Okay. It is the transmitter part, it is the receiver part. Okay. The transmitter part, it sends the information through a medium or channel to the receiver. Okay. Here at the channel, due to the medium, it may distort the signal passing through the channel. Okay. And due to some electric signal presents, some noise also present in the channel, and due to this noise, whatever information you are passing from here, it may corrupt. Okay. If binary information is transmitting, then here 0 may be converted into 1 or 1 converted into 0, may be, not necessary. Okay. Okay. We have to do some mechanism to reduce these type of errors. How this 0 to 1 or 1 to 0 can be minimized. Okay. Then to minimize those errors occurred in the channel, we will do some channel encoding. Okay. We will add some redundant bits with the output of the source encoder bits, so that those redundant bits are encoding methods, okay, that will be decoded at the channel decoder, okay, to detect the errors and correct the errors occurred in the channel. Okay. And basically in this information theory and coding subject, block coding and convolutional coding and their decoding methods, that we will discuss here, that is in the unit 4th and 5th basically. Okay. And about channel, we will discuss channel capacity theorems, channel coding theorems, like that we will discuss in the unit 3rd. Okay. Digital modulation and demodulation block, basically this is the part of subject digital communication mainly. It is not the part of the syllabus of this information theory and coding. But about source encoder, source decoder, these we will discuss about source, entropy, probability, statics, like that, that in the unit 1st we will discuss here. Unit 2nd, the source encoding and decoding, we will discuss in the unit 2nd. Okay. See, this is all about the syllabus, whatever we will discuss in that subject. Here the source may be analog, it may be analog, it may be discrete. That information from analog or discrete, that is converted into a binary information. Okay. And whatever the methods of conversion, okay, that we will discuss here. Okay. And not only that, but the entropy of the source, basically the average uncertainty of connected with the each symbol of that source, that we will discuss about all about that in the unit 1st. Okay. Okay. Then this is all about basic elements of the digital communication system. Here you can say that here output is analog or digital, then converted into this, it may be in binary form. Okay. In channel encoder, again it is in binary form, and channel encoder output after using adding some redundant bits, again it is in binary form. In digital modulation, it is converted into some waveforms. Okay. In waveforms, it will travel through the channel. Okay. Again it is converted into the binary form, then decoded through channel decoding. The method as we use in the channel encoding, again it is in the binary form, and at the source decoder, okay, the same decoding method, okay, that you will use in the at the source encoder, it is a reversible method, we will use at the source decoder. Okay. And again here information, it may be binary or analog, whatever, and goes to the destination. Okay. Then this is the complete block diagram of digital communication system. Okay. And here in the next slides, basically those elements about source, then information source, then there is a source, suppose S, it provides some output that may be analog or digital, okay, corresponding. We can characterize these source, analog information source. If output is discrete, then discrete information source, output is digital, then the digital source. Okay. See, any source, suppose a discrete source, we are taking a discrete source, the discrete source S, suppose it has some symbol outputs S0, S1, S2, S3, suppose. Okay. Then every symbol at the output has some its probability, okay, like that S0, the probability of occurrence of the symbol S0 at the output that is the P naught. P naught is the probability for the symbol S naught occurring at the output. Same way P 1 is the probability for symbol S 1 occurring at the output of source. Similarly, P 2 for S 2 and P 3 for S 3. Okay. These probabilities are used to find the average entropy of the source. Okay. Before going in detail of the entropy, okay, we can discuss, that is how we calculate the average value. Suppose average value of the information, average information we have to find for the given source. Okay. Then we have to find the information contained with each symbol first. Okay. Then information contained with each symbol, for information contained with symbol S naught, that is I naught, information contained with the symbol S 1, that is I 1, similarly I 2 and I 3. Okay. These information contained with each symbol is nothing but depends on the its probability. Basically, you may say like that, uncertainty contained with each symbol. Okay. Like that, you may say, we can take some examples of this. Like that, there is a source with this type of output, okay, and the information basically that is calculated as the uncertainty measure. Okay. Uncertainty contained with the each symbol, uncertainty, and it is connected with the surprise with that symbol. Okay. That depends on its probability. Suppose for example, we can take example, suppose sun rises in the east. Example is the sun rises in the east. When sun rises in the east, what is the probability? Sun rises in the east, that is the P is equal to 1. Everyone knows then sun rises in the east. Then when probability is 1 and we are saying that sun rises in the east, it is having 0 information. There is no information with this message that sun rises in the east. But if we say that another example like that, suppose China attacks on USA, okay, I think there is a no probability. Okay. Suppose the event having no probability, 0 probability, and that event occurs and this having maximum information, okay, in that event. Okay. Now these probability and information, these we can mathematically correlate with each other. Then here, because I is 0 for P is equal to 1, okay, and I is maximum and P is equal to 0, then I is inversely proportional to P. It is correct. Okay. Now to correlate this thing, we can say, because I is 0 for P is equal to 1, it may be a logarithmic nature. I is equal to log of P, log of 1 upon P, sorry, log of 1 upon P. Okay. When P is 1, then log of 1, I is 0. When P is 0, I may be infinite, maximum. Then this is the way we can correlate probability with the information, okay, or information or surprise. Like that, when probability is 1, surprise is very less, there is no surprise, then information is 0, okay. And uncertainty is also 0. But when probability is 0 and it happens, then surprise is maximum, information is maximum, uncertainty is maximum, okay. Then we can mathematically correlate probability with the uncertainty, surprise or information, okay. Then this is the method, so that we can correlate. Now, here in the last example, given example, source S with these outcomes S naught, S1, S2, S3 with their probability P naught, P1, P2, P3, okay. Then average information can be calculated. I naught is the log of 1 upon P naught, log of 1 upon P1, log of 1 upon P2, log of 1 upon P3 and so on. In this way, information can be calculated at the source, and this information we can take its average value also, average information. Then how can we find its average value? I naught, I1, I2, I3, can we find its average? How can we find its average? Normally we take average, that is I naught plus I1 plus I2 plus I3 divided by 4, but that is not the correct way to find the average. Normally we find average I naught I1 plus I2 plus I3 divided by 4, okay. This is the average conventional method to find the average value. Basically what we are doing here to find the average, we are multiplying every component of information by 1 by 4. So, 1 by 4 I naught plus 1 by 4 I1 plus 1 by 4 I2 plus 1 by 4 I3, and 1 by 4 is nothing but the equiprobable if all the symbols are equiprobable, okay. Then the probability will be 1 by 4. Then that equiprobability is multiplied with each information contained in those symbols, each symbols, okay. Then we find the average. Then this average method is correct if each symbols are equiprobable, then we can find the average value. But if these symbols are not equiprobable, their probabilities are different, then how can we find the average value? Then that average information can be calculated as I naught into P naught plus I1 into P1 plus I2 into P2 plus I3 into P3. This is the method to find the average information contained in each symbol. Individual information, that is given by this one, and their average can be calculated by this way. This average information, it is called the entropy of the source, okay. This is the method to calculate the entropy of the source, okay. Entropy of the source, that is the average information, can be calculated in this way, okay. Then entropy of the source, we can write entropy H equals to summation I equals to 1 to n Pi II, okay. Average information or entropy can be calculated by this method, okay. Now, this method will be used to entropy to calculate the entropy or the average information of the source, okay. Now, next is the source encoder, source decoder, okay. Then in the source encoder decoder, some source encoding and decoding methods we will discuss. Okay. How information in the binary that is encoded in such a way that it is decoded uniquely at the source decoder. In binary we may convert by using any method, but using some unique method, so that it can be decoded uniquely at the decoder, source decoder. Those methods we will discuss in the source encoder. And next, channel encoder, channel decoders, channel errors occur, digital modulation and demodulation, that only the elements of the basic digital communication system, not in the complete syllabus. Okay. Then as I already discussed how channel errors will be corrected using the channel encoding methods, using some block codings, some convolutional codings and their decoding methods. Okay. That we will discuss later in the next lectures. These are some references books that we will that you can use for your reference. Okay. Then these are the complete slides for this lecture. Here we have discussed basically the syllabus, whatever covered, whatever we will cover in the complete subject in first unit, second unit, third unit, fourth and fifth, that we have discussed already using a digital communication system block diagram. Okay. This is the method, so that you can be aware that how the units are will be covered using this digital communication system block diagram. Okay. Thank you.